Hey guys, this is the next sheet for homework. This would be called homework 2, quarter 3. Okay, and this is due, I guess, Monday or Tuesday, depending on when you had me. Okay, so let's do it. So remember, you can write some of this stuff on the front or the back or on another piece of paper, staple it, but just hand in this one sheet of paper. So from the midterm, the first question says, a frequency table summarizes the distribution that 140 patients in an emergency room of a small hospital waited to get attention at last month. Okay, so this is didn't wait at all, 10, 20, 30, 40, 50, 60, 70. Okay. And I don't know if you're noticing this, but they're accumulating these frequencies, if that makes sense. So if I add all these up, I get 140. So what that means is that somewhere less than that was 5. So I'll just make that 5. Less than 10. And then another were at least 10, but less than 20. So that's this next one, 5, 10, 15, 20. So almost 25. That would be 24. And then this one, 5, 10, 15, 20, 25, 30, 35, 40, 45. So I'm almost running out of paper here. Something like this. And then this one, 35, 40. And that one's 5, 10, 15, 20. 19 is just under 20. And then we have 7. And 2. Okay, so here's our data. And it says, which of the following would be a possible value for the median? Well, again, the median is the 70th patient because the median's the number in the middle. So you can kind of add these up, but I also made a graph here so that it would be obvious. You know the median is somewhere in here. So let's add these up. So it'd be 5 plus 24, which is 29. And then I'm going to take 70 minus 29 to get 41. Yeah, so the 41st patient, so somewhere right there, this is half of those 140 patients, the 41st. There you go. So we know that the median lies somewhere between 20 and 30. So the median lies somewhere between 20 and 30, which means A and B are on a reasonable answers. And the inner quartile range is the middle, the middle of the top minus the middle of the bottom. Quarter 3 minus quarter 1. So the middle person, so divide 70 in half. Again, we get 35, the 35th person. So I'm going to add that. So that'd be 5 plus 24 is not yet the 35th person. So the middle of the bottom half is actually in this range as well. Let's see the middle of the top half. Then we'd count down by 45. So if we count down by 45, so that'd be 2 plus 7 plus the 19. So 7. So it's in here somewhere. Is quarter 3 is in here and quarter 1 is in here. So I would be subtracting just this amount. I couldn't, the highest this number could be would be like 39.9, and the lowest this number could be would be exactly 20. So if I subtract those two numbers, I get 20. So it can't be 25. That way, I know it has to be A. Okay? Let's try the next one. It says a test for extraneous or extrasensory perception, or ESP. That means when you read somebody's mind. Is asking them to tell them, what shape am I thinking of? Circle, star, triangle, diamond, or heart. It appears on a computer screen. On each trial, the computer is equally likely to select any of the 5 shapes. Suppose that researchers are testing a person who does not have ESP, and so it is just purely guessing. What is the probability the person guesses the first 4 shapes incorrectly? Okay, so you're gonna get 5 guesses. So you could think of this as a tree diagram. You're gonna first guess and you get it right or wrong. Second guess, you're either gonna get right or wrong. And so if you got the first guess wrong, the second guess is either right or wrong. So this is kind of in your brain, and they're saying, what's the probability that a person guesses the first 4 incorrectly? So they'd be wrong, and then wrong, and then wrong, and then wrong, and then right. So at the end of a tree diagram, we can multiply each one of these to get our answer. So what would that be? Well, the probability of wrong, 4 out of 5 times would be wrong. So that'd be this first guess. And then again, 4 out of 5 times you'll get it wrong. And then again, 4 out of 5, you'll get it wrong. And then again, 4 out of 5, you'll get it wrong. And then this last time, you're gonna get it right. Well, only one of the shapes would be right. So this is the probability of wrong, and this is the probability of right or correct. So C is our answer. Cool. Let's go to the next one here, and then I'll do a video with just these two. All right, it says the partially complete table follows. So this cannot be a probability model unless all of these add up to 1. So let's finish out making it a complete probability model. Okay, so those add up to 0.7. So that means this is 0.03. So I add these up. And you could think of that as X because you don't know what it is. You know those have to add up to 1. So when you combine these, you get X plus 0.7 equals 1. And when you subtract 0.7 on both sides, you get 0.03. Okay, now it says, select a student from this class at random if a student earned a score of 3 or higher. So this would be 30% of the time you'll get a student that got a 3. 25% you'll get a student that's 4, and 15% of the student you'll get a high. So I can add up these, and it's just like adding up branches on a tree diagram, because once the entire tree gets to the end, they should add up to 1. Okay, so let's add these together. So 0.3, 0.25, 0.15, I get 0.70. Oh, but that's not what they asked. I'm gonna need this though. It said, it doesn't say what is the probability they scored a 3 or higher. It said if they earned a score of 3 or higher. So what we're thinking is out of 100 students, 70 of them. So what's the probability that they got a 5 given they got a 3 or higher? That's what they're asking. So the denominator has to be the number of students or the probability of the student getting 3 or higher. Okay, so I could think of it in terms of if 100 students took the test, I'd assume 70 got a score of 3 or higher, or the probability of getting a score 3 or higher is 0.70. And then it says, what's the chance that they got a 5? So 15 out of 100 got a score of 5, or you could do it in terms of the probability. So notice this or this will give you the same number. So let's calculate that number. 15 divided by 70, I get 0.214. And that's my answer, B. Great job, guys. Check out the next video.